Now, in the previous lecture, we know this difference for the cosine formula and the sum formula for cosine. The two formulas were introduced and they can be proved. So we have the two identities. Yeah, cosine for a sum, cosine for a difference. How can I derive this other two identities? And then once we have some sign of a sum or sign of a difference, then we just can do more things. Okay, so let's see. We know also a cofunction identity. Cofunction identity, right? Immediately can make the cosine sign. Yes, so this identity involves the sine cosine. So in order to get the sign of a sum, we can see this cosine function and sine function can be involved in a cofunction identity. So let's think of this identity. Instead of theta, we replace the theta with alpha plus beta. That is, in this identity, we substitute alpha plus beta into theta. So this identity is still true because we know it's a cofunction identity, and it is true for any theta. So now we replace it with alpha plus beta. So when theta is alpha plus beta, you see cosine of half of pi minus alpha plus beta. The right-hand side will be sine of alpha plus beta. So we get a new identity. So this should be still true because it's true for any theta. Now theta is very specifically this sum. Now since go from here, then we will be able to find a formula for sine of a sum. Okay, so sine of this sum is equal to cosine of difference of half of pi and the sum of alpha beta. And then we continue from here. So you see this difference, we can put minus alpha minus beta, right? Because minus the sum means minus alpha minus beta. So we group the first two terms together. So half of pi minus alpha, and then minus beta. And that becomes a difference for cosine. So we can use difference for cosine because that identity is already there. We can use it. So this is a first angle in the formula, second angle in the formula. So just apply the cosine of the first angle, cosine of the second angle, plus sine of first angle, sine of second angle. So we just simply apply the difference formula for cosine. After we apply difference formula for cosine, which is the formula we already know that is true, then just a very specific application, right? After we do that, then what's the cosine of this? That's the cofunction identity. Cosine of this difference is actually sine alpha by applying cofunction identity. Sine half of pi minus alpha is cosine alpha. And And then we get a formula, which is the sum formula for sine. Sum formula for sine can be summarized as this sine of the sum alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So that's the formula. And once we have the sine of a sum, can we get sine of a difference? Sine of a difference. Yes, we can write it into sum. Just to put a sum plus a negative beta. So alpha plus negative beta is the same as alpha minus beta. So we write it into a sum. Once we have the sum of two things, then we apply the formula already established. Yes, sine of a sum. You see, we have the sum, then we can apply. So sine of this sum is the sine of first, cosine of second, plus cosine of first, sine of second, which is negative beta second. So you see, with one identity, we can easily derive the other identity, which is sine for difference. So once we have the sine for a sum, then we can derive the identity of sine of difference, because sine of difference is just the sine of alpha plus negative beta. So now we get, by simply applying this identity to this this particular case, you see, the sum is the first, second, right? Sine of a sum is always, just do this according to the identity, sine of the first, cosine of second, plus cosine of first, sine of second. Okay. So we write the difference as the sum, the form of a sum. And then we get another formula. Sine of a difference is sine of first times cosine of the second, which is beta, minus cosine of first, sine of second. So when we get this formula, when we see the cosine of the second here, negative beta is the same as cosine beta. And then for the sum, so sine cosine plus cosine sine. Cosine sine of negative beta should be negative of sine beta, because sine is odd function, is an odd function. So that's why we get this conclusion for the difference for a sine. So to put them side by side, it's very clear that we see the difference. Sum for a sine, right? This is the sum of the two products. Difference for a sine. Here you see the difference of these two products. Yeah, so also you see for the sine alpha plus beta, this is a mixture of sine value and cosine value, sine alpha cosine beta plus cosine alpha sine beta. So it's a product of sine cosine of these two angles respectively. And this one also minus, so sine alpha cosine beta minus cosine alpha sine beta. So different than the cosine formula. You see that the product of two cosines together. So be aware of the differences in the formulas when you apply them. So do not make a mistake, because some similarities also differences. So what if we want to get a tangent for the sum? So if we divide the sine by the cosine of the sum, then we get tangent, right? We have an identity. You see, tangent of a sum is equal to sine of the sum over cosine of the sum. So just simply sine over cosine is tangent. So we can get a sum formula for tangent. Okay, so here is the sum formula for tangent. Okay, let's go ahead. Substitute this and this. So let's numerator is sine of the sum, and then you substitute, and the denominator is cosine of the sum, then you substitute. So here, by the sine formula of a sum, right? And the denominator, this part, is cosine formula for the sum. So we replace, and then we get this formula, a formula for tangent of a sum. But for the tangent function, tangent of the sum, we hope we can use tangent value, tangent of alpha beta. Can we possibly get tangent of alpha beta? So we look at the current version. It has sine, cosine of alpha and beta. And then suppose we divide both numerator and denominator by cosine alpha, cosine beta. Let's divide numerator by cosine alpha, cosine beta. Denominator also we divide it by cosine alpha, cosine beta. Right? Once we do, we don't change the value. We just divide both numerator and denominator by the same quantity, which is this cosine alpha, cosine beta. So what happens? So let's just want to reduce it. That is, once you divide that, that means each term in numerator, right, will be divided by, you see, each term in numerator is divided by this cosine alpha, cosine beta. Also, each term in the denominator also divided by the cosine alpha, cosine beta. So once we do that, and we can see this can be reduced because the cosine beta is canceled, and this becomes a tangent alpha. And you see cosine alpha is canceled. This becomes a tangent beta. And then we cancel common factors, right? This becomes 1. So let's write, it's basically tangent alpha plus tangent beta, and this is 1. And what else? And we can again look, this one is a tangent alpha times tangent beta. So 1 minus tangent alpha tangent beta. Now the tangent of alpha plus beta becomes some quantity in terms of tangent alpha and tangent beta. So we don't have to use the sine cosine of alpha beta to calculate the tangent of the sum. So the final result we're arriving is the sum for tangent, because we have now sum for cosine, sum for sine. Now we have sum for a tangent, sum for a tangent. And it is in terms of tangent function values of alpha and beta. So this formula is the tangent for sum. But of course, you want to have tangent for the difference, right? So tangent of a difference, alpha minus beta, how can we get a formula for this? If we have the sum and we want to get a formula for this difference, so we want to write it as a sum so we can apply the already established formula. So let's write the difference into a sum. No, it is a sum. So you see alpha minus beta is actually alpha plus negative beta. So now using this formula, using the formula. So you see this in this formula, when you have two angles, tangent of first plus tangent of second over 1 minus tangent first times tangent second, right? So let's go ahead. This is the first and second. So let's get numerator is tangent of first plus tangent of second over 1 minus tangent of first, tangent of second, which is now negative beta. So we are simply applying the formula for this case. So now we can do one more thing, that is tangent negative beta is negative tangent beta because tangent is an odd function. So we can put a negative outside of, put it here. And tangent negative beta is negative tangent beta. So we can take this negative outside here. So negative will become positive, right? So that in front of beta, we get just simply beta. That negative sign can be moved outside because tangent beta is odd, is an odd function. Tangent negative beta is negative tangent beta. So, so the previous negative becomes positive. So I just put positive here. So you see, we have arrived at a formula for this tangent of a difference. You see, tangent for a sum with a sum in the numerator, minus in the denominator. Tangent for a difference with difference in the numerator, but plus sign in the denominator. So we can put the two formulas side by side and do a comparison. Okay, that's a clean version to show tangent of a difference by applying that formula of tangent for a sum, right? We can arrive at this result. And then now we have not only tangent for a sum. Also, this tangent of a difference. Okay, so now we have two additional formulas. You see the sum and difference formulas for tangent. And look at this formula. So when it's a tangent of a sum, you have sum in numerator and minus the sign in the denominator. When it's a tangent of a difference, you have difference in the numerator. But a sum in the denominator. So it's well, two additional formulas. So we have so far difference, sum, formulas for cosine, and difference and sum formulas for sine, difference and sum formulas for tangent. Let's use these formulas to find, for example, the exact value of sine 75 degrees. So 75 degrees can be written as sum of special angles like 45 and 30. Together, 75 degrees. Yeah, so this, we don't know, right? Sine 75 looks like we cannot find exact value of sine 75. However, if we write it as a sum of two special angles, and we can apply the sum formula for sine. And then we can apply that formula. It is sine of the first times cosine of the second plus cosine of the first times sine of the second. And the 45, 30 degrees are special angles. We know their values. We know sine 45 degree is this number. Cosine 30 is this number. Cosine 45 and sine 30. So we have all these numbers, then final answer for the sine 75 degree can be found. And that's the exact value. So we just applied the sum formula for sine, right? We applied sum formula for sine to get exact value of sine 75 degree. Here is another problem. So if you want to find exact value of this expression, is that possible? We do not know the sine of 92. It's not a special angle, and how to find it, it is not simple, right? Cosine 62 degree, we don't know. That's not a special angle. So, and we don't know sine 92, cosine 62, sine 62. We don't know their exact values. So to get exact value of this expression, it's impossible if we simply depend on the sine cosine of each of those angles. And however, we recognize the sine cosine minus cosine sine, that is a sine of a difference. That is 92 minus 62. You see, if we replace with alpha, we can see better. Maybe we can recognize that pattern. It's a sine alpha cosine beta. Here, alpha is 92 degree, right? The angle. Beta is 62 degrees. So minus cosine alpha sine beta. You see, sine cosine, sine alpha cosine beta minus cosine alpha sine beta. That is the difference formula for sine. Okay, as soon as we recognize this, it can be written as the sine of a difference, which is sine of 30 degree. The 30-degree angle is special. It is a special angle, and we know it. Sine 30 degree is half. And that's the answer. So we just found the exact value, which is half of this expression. And using the difference for sine formula. Yeah, that's the formula we used. So it looks, you see, identity, right? It's a real specific application of that identity when alpha is 92, beta is 62. You see, that's the difference of alpha and beta. So we applied so these identities, you can use it from one direction to the other, or from, yeah, depending on which side is more convenient for you. Now let's look at another problem. And this problem is an identity for us to verify. So can we verify tangent at theta plus pi over 4 is equal to this? How do we verify? But we notice this is a sum, right? We just need to apply sum formula for tangent because we already know there's such an identity sum formula for tangent. Remember, it is the tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. So that is the sum formula, sum for tangent formula. So with that formula, if we apply this formula to this, that means alpha is theta, beta is pi over 4, right? Just take, we just, whenever you see alpha, let's replace it with theta. Whenever you see beta, you replace it with pi over 4. And then tangent alpha will be tangent theta. Tangent beta will be tangent pi over 4. So I'm directly applying this formula. And then 1 minus tangent theta tangent pi over 4. You see this, the formula in green is already established. Right now, what I'm doing is just use it. So for specific case, you see alpha, beta. So whenever you see alpha, you replace it with theta because it's identity. That means it's true for whatever. So when alpha becomes theta, beta is pi over 4. So now we can see pi over 4 can be further reduced because pi over 4 has a tangent value 1, right? So we can put a 1 here. Whenever you see this, this is a 1. This is a 1. And then this means the numerator is tangent theta plus 1, which is the same as 1 plus tangent theta. Denominator is 1 minus tangent theta. Because tangent theta times 1, right, still tangent theta. So we have denominator as 1 minus tangent theta. So finally, we have shown this identity. We have shown this identity. What we did is we started from the left-hand side, and by applying the sum formula for tangent, and then step by step we reduce, we arrive at the other side. So we have verified this identity. So that is a quick look at this formula. We try to apply it to this situation. In this situation, so you see this is a sum of two angles, right? Just apply it. Sum formula for the tangent. So we apply, we get this. And then because once we apply, we get this immediately. But we notice tangent pi over 4 is 1. So that is easy, because this is 1. 1 times anything is still that value, right? Tangent theta times 1 is still tangent theta. So this becomes 1. So numerator becomes 1 plus tangent theta. So this is 1 plus tangent theta numerator. Denominator becomes 1 minus tangent theta, because, yeah, this is 1, keep in mind. 1 times tangent theta is still tangent theta. So denominator becomes, so we have started from the left, arrived at the right-hand side, and verified this identity. Yes, that's so far you we have these identities, and you will continue to get familiar with them and feel more comfortable using them.